Ladies, let's complete our study of graphing trigonometric functions by looking at the graph of cotangent. To do that, I want you to evaluate these points that these x values that I've picked for you in cotangent. So let's evaluate the cotan of 0. Remember that on the coordinate plane, or the unit circle, 0 degrees is located here, and the ordered pair is right 1 up 0. To calculate cotangent is the reciprocal of tangent. We know that the tangent is y divided by x, so cotangent is x divided by y, or 1 divided by 0. Anytime we divide by 0, we are undefined. So the cotangent at 0 is undefined. Pause the screencast and complete this table. When you have completed this table, turn the screencast back on and check your answers. Let's see what we've got here. Cotangent of pi over 4, that's 45 degrees. The tangent of 45 degrees is 1, and the reciprocal of 1 is 1. Cotangent of pi over 2. The ordered pair at pi over 2 is 0, 1. So the cotangent is x divided by y, which is equal to 0. 3 pi over 4 is in quadrant 2, therefore it's negative. Pi radians, the ordered pair is negative 1, 0. And again, we would have x divided by y, which gives us undefined. 5 pi over 4 is in quadrant 3, where cotan and tangent are positive. 3 pi over 2, the ordered pair is 0, negative 1. So 0 divided by negative 1 is 0. 7 pi over 4 is in the fourth quadrant, where cotangent and tangent are negative. And finally, we're back to 0 or 2 pi radians, where we get undefined. Please plot these angle measurements on your coordinate plane below and plot the corresponding y coordinates. So pause the screencast, plot, and then check. All right, so let's check this out. Notice that the asymptotes are at 0, pi, and 2 pi. Notice that cotangent rises to the left or falls to the right. So think about that in terms of tangent. Tangent rises to the right. Cotangent, which is the reciprocal of tangent, falls to the right. Tangent has asymptotes at pi over 2 and 3 pi over 2. Well, think about that. When tangent is undefined, the reciprocal of undefined is 0. Notice where tangent equaled 0, cotangent is undefined. So let's answer a few of these analysis questions. The length of one period, notice that these asymptotes are pi radians apart. So the length of one period for cotangent is pi radians. Cotangent is undefined. Everywhere there is an integer multiple of pi. So integer multiples of pi. So 0, pi, 2 pi, 0, 180, 360, so on and so forth. For our starting point and ending point, notice it's at the asymptotes, and so we will use 0 to pi. So when you are calculating any phase shifts for cotangent or any period changes, you will use the inequality from 0 to pi. To calculate the period length, we will use that period is pi divided by the absolute value of b. Let's practice a couple of these. Example G, y equals the cotangent of x over 2. To begin with, I'll identify A. A is equal to 1, so we know that we will have positive 1 and negative 1 on our y-axis. B, which is the coefficient of x, is 1 divided by 2. So our period length is pi divided by 1/2. If we keep it, switch to multiplication and flip it, our period length is 2 pi. So if we take x divided by 2 and write our inequality from 0 to pi, let's solve for x. I'll begin by sweeping the fraction, multiplying through by 2. So our new inequality is 0 is less than x is less than 2 pi. So that tells me that I have asymptotes at 0 and 2 pi. Remember from our earlier examples of other trig functions, we divide the period into 4 equal parts. Recall that cotangent rises to the left, so at our quarter mark will be at positive a, then the x-axis, then negative a. And there's our cotangent. If I ask you to draw a second period, where would the second or the third asymptote lie? On how many radians? Hopefully you said 3 pi. Whoops, hopefully you did not say 3 pi. Sorry about that. Let's think about that again. We know that the distance between these two asymptotes for this function is 2 pi radians long. Therefore, the distance between the second pair of asymptotes should also be 2 pi radians long. So 2 pi plus 2 pi is 4 pi. And then we'll divide that into 4 equal parts and plot our graph. Let's take a look at cotangent. For example, H. I know that A is 1. So that gives me positive 1 and negative 1 on the y-axis. The period, we need B for the period. B is 2. So our period length is pi divided by 2. Let's go ahead and write our inequality. Our inequality is 2x minus pi over 2 is less than 0 is less than pi. And I want to sweep the fractions, so let's multiply by 2. Our new inequality is 0 is less than 4x minus pi is less than 2 pi. Ladies, take a moment and isolate x, please. So you should have new asymptotes at pi over 4 and 3 pi over 4. So we'll go ahead and label those. And then if we divide this into 4 equal parts, our midpoint is at pi over 2. Okay, so when we graph cotangent, cotangent rises to the left or falls to the right. So at our first quarter mark, we will be at positive 1, then 0, then negative 1. Again, if you are going to draw a second period, your asymptotes should be equidistant measures apart or equidistant radians apart. For our periods pi over 2, the distance between the first pair of periods is pi over 2, and that should also be the same distance between the second set of periods. So 3 pi over 4 plus pi over 2 is 3 pi over 4 plus 2 pi over 4, or 5 pi over 4. Missed it. Let's finish up the last example. I want you to pause the screencast and set up and solve your inequality and label the y-axis appropriately. The value of a is -4. You should have placed 2x between 0 and pi, and dividing through by 2 gives you 0 for your first asymptote and pi over 2 for your second. Now, it's important to note that because a is a negative, cotangent will no longer fall to the left, but it will, let me repeat myself. Cotangent will no longer fall to the right, but the negative causes a vertical reflection, so cotangent will rise to the right. So -4, 0, +4. This time, let's draw a period to the left. The distance between asymptotes is pi/2, so this value should be labeled as -pi/2. Ladies, I hope this helps you in graphing cotangent. See you next time.